Okay, so you guys should start off with this worksheet over here. I would like you to go to this link and play some rounds of Deal or No Deal. If you don't want to type this entire link in, it is right on Google Classroom. So when you get to that link, you'll hit play, and then it'll take you through some ads. Just go ahead and exit out of all those ads, and then it'll take you here. So for example, if I want to play, I'm going to choose maybe case 2, and then after that, I'm going to choose a few more cases, and I'll go through that, play it a few times to see what you will get. So to just talk about some of the questions on the back, obviously you probably looked at probability if you were considering whether or not you want to take the deal. For number 2 specifically, if we want to think about the first 6 cases, that's the probability that's happening in the video that I will also show you, which is this link up here. If you think about it, well, to get 0.01, you already chose case 26, so now there's 25 cases left. So there's a 1 out of 25 shot that you get the 0.01. Then we now remove that case, so we have 24 cases left, so there's a 1 out of 24 chance that you get that one. 1 out of 23, so on and so forth. We multiply those down for the first 6 cases there. Hopefully you're able to get through the rest of the questions. If not, we can talk about them a little bit tomorrow. So let's review a little bit. If we draw 2 cards at random from a standard deck, and the first card is replaced before the second card is drawn, what is the probability that both cards will be hearts? So let's think about it. If we're replacing our cards, then that means we're going to have 52 cards each time. So let's go ahead and write 52 each time. So the first time, well, if you pull out that sheet that has all of the possibilities for a standard deck of cards, you will notice that there are 13 hearts. If we go ahead and replace that card, then there's still going to be 13 hearts. And what do we do with these 2 fractions? Well, we multiply them. So 13 times 13 is going to be 169. And then 52 times 52 is going to be 2704. And again, you do not need to simplify that down. If you want to, you can. Next question, if the first card is not replaced before the second card is drawn, what's the probability that both cards will be hearts? So this time, the key word here is not replaced. So if we're not replaced, we start with 52 cards, but then after 52 cards, if we take one away, we now only have 51 cards. So again, my first card, I'm going to have 13 possibilities for hearts, and then assuming you picked a heart, well, how many hearts are going to be left? The answer is 12. So this time, when you multiply them, we have 13 times 12, which is going to give us 156. And then on the bottom, we now have 2,652. And again, you can check all this with your calculator. Okay, now what I want you to do is to have out this graphic organizer. It's one of your green sheets, so I'll give you a second to go ahead and pull that out. Once you have that out, we're going to focus on the conditional. So we're going to be writing in the conditional given that blurb here. So if you're ready, here we go. Conditional probability, that is just another way of saying given that. So something that already happened, what can we use that information to predict something that will happen now? So the way we read this is the probability that A happens given that B already happened. Again, the probability that A happens given we know that B already occurred. Probability that A occurs given B. Sorry for the sloppy handwriting here. I'm using my mouse. Okay, so again, the probability that both happen, so that's thinking about something that's repeating several times, and then over the probability that B occurred here. So let's take a look. This will probably make a little bit more sense when we actually try out some scenarios here. So again, all this should be going in that little box that says the conditional probability here. So now I'd like you to go to this worksheet that the substitute should be handing out to you, called Conditional Probability. And we're going to go ahead and take a look at the first few questions. So the first question here. A math teacher gave her class 2 tests. 25% of the classes passed both tests, and 42% of the classes passed the first test. So these are the key things here. 25% passed both, 42% passed the first test. what percent of those who pass the first test also pass the second test? So in this case here, we want the probability that they pass the second test, given that they already passed the first test. Okay, what percent of those pass the first test also pass the second test? Okay, remember, from our equation, we know that it's the probability that both occurs over the probability that B occurs. In this case, our event B is the first test. Okay, so we want both over the first test. Well, both is 0.25. And then the second test, or sorry, the first test rather, is 0.42. And if we go ahead and actually do that, so 0.25 divided by 0.42, that's going to give us 0.595 or 0.6. So that's the probability. 60% of those who pass the first test will also pass the second test. Pretty good. Okay, next question. The probability that Sue will go to Mexico in the winter and to France in the summer is 0.40. The probability that she will go to Mexico in the winter is 0.60. Find the probability that she will go to France this summer, given that she just returned from her winter vacation in Mexico. Okay, so remember, we want the probability that she's going to France, we'll say F for France, given that she just returned from her vacation in Mexico. If you notice, we don't really have a probability of both in this case. So in some cases, you might have a conditional probability that is a part over a part. So you may want to add that to your graphic organizer if you get a chance, because that is also possible. Okay, so what's the probability that they went to that they go to France, given that they went to Mexico? So again, let's start with that they went to Mexico. Well, they went to Mexico is the 0.6, because that's given, that already happened. So now we want that they go to France. Well, that's the 0.4. So now we have 0.4 divided by 0.6. And 0.4 divided by 0.6 is approximately 0.67. Alrighty, moving on. We now have this nice little chart here. So it says 3,179 people were surveyed about their age and employment status. So we have all the age groups here. We have from 0 to 17, 18 to 25, 26 to 34, 35 to 49, 50 and older, and then our total categories this way and our total categories this way. We then have full-time employees, part-time employees, unemployed, and our total as well. So now the first question here says, what's the probability that they were in this 26 to 34 age group? Okay, so let's think about this. If I want the probability that they're in the 26 to 34 age group, remember, it is what you want, so the 26 to 34 age group, out of your total number of employees. Well, how many people were surveyed here? Well, the answer is the entire population here was 3,179. So 3,179 is our total. And we want the probability that they are in the 26 to 34 age group. Well, how many total people are in the 26 to 34 age group? That would be the 442. Okay, so the probability that they are in the 26 to 34 age group is 442 over 3,179. Let's look at the next one. So the next one says, what's the probability that they are part-time? Probability that they are part-time. So in this case here, again, we want our total number of people here. That's the 3,179. And then what's the probability that they are part-time? Well, part-time people, we're now going in this category and we're dropping down. Part-time total is 775. So 775 is on top, and then the 3,179 is on the bottom. So I'd like you to keep going through the rest of this worksheet, specifically these problems using this chart. Please know that not all of them, it's going to be the 3,179 as your total amount here. You need to go based on your category. I will post the answers so you can check them over, but again, please try to do as many as possible. You have the front and back to do for this worksheet. When you are finished going through this worksheet, and again, if you can't get all of them, that's okay, but please do the best you can. You may go to working on your project for the rest of the period. Good luck.